Gold remains a highly desired metal today, and the industry generates nearly $200 billion in revenue annually. The first step is to find places that may have gold. Geologists and mining companies do thorough research, prospecting, and geological studies to locate areas with promising gold deposits. They might study geological maps, examine soil samples, and use advanced methods like remote sensing or geophysical surveys. Once a potential gold deposit is found, they prepare the site for mining operations. This includes clearing plants, building access roads, and setting up camps and facilities. Once everything is ready, it's time to start mining gold. But have you ever wondered how this incredible metal is formed? Well, hold on tight as Superstructures takes you on an unforgettable adventure to discover the origins of gold. Most gold comes from lode deposits, also known as vein deposits, which are concentrations of gold and other metals found in cracks within rocks. These deposits require a mining technique called hard rock mining. The process involves extracting gold-bearing rock, known as ore, by drilling and blasting. Miners go deep underground, descending more than half a kilometer, carrying specialized machinery designed for drilling. The drilling equipment includes a long-hole drill rig, which consists of drill steel, a drilling machine, and a source of compressed air. The long-hole drill rig is placed in the desired underground location. The drill steel is then inserted into the rock or ore face, and the drilling machine starts rotating while feeding the drill steel into the rock. Compressed air is forced through the center of the drill steel to help remove the drill cuttings from the hole. The arrangement and layout of the drill holes are carefully planned based on the specific mining strategy and the characteristics of the deposit. Mining experts and geologists employed by the mining company prepare these plans. Factors such as the size, spacing, and angles of the holes are determined to optimize the fragments produced during blasting and ensure the safety and efficiency of the entire process. After the drilling process is completed, the holes are prepared for explosives by cleaning them of any debris and installing components like stemming, detonators, and initiators. Once all the necessary preparations are done, the explosives are carefully placed into the drilled holes, and the blast is initiated from a safe location. The explosion breaks up the rock or ore, creating manageable fragments that can be easily handled, transported, and further processed. After the blasting with explosives, miners use a mucking machine to transfer the ore to carts, which are then taken to the main shaft and brought above ground to the mill. The use of mucking machines streamlines mining operations by automating the process of removing loose material, which would otherwise require manual labor or the use of other equipment like loaders or trucks. Next, the gold-containing materials such as ore or scrap is prepared by crushing and grinding it into smaller particles and size of gravel. The mill then pulverizes the gravel to the texture of beach sand, increasing the surface area for subsequent chemical reactions. The factory adds a water and cyanide solution to the pulverized ore. Another mill further grinds it into a mud-like pulp, which flows into large settling tanks. The wet solids, being heavier, sink to the bottom, and the water at the top drains to another area. Workers transfer the wet solids into an agitation tank and introduce air through a process called aeration or air agitation. The purpose of aeration is to introduce oxygen into the slurry. The oxygen triggers a chemical reaction between the cyanide and the gold trapped in the ore, causing the gold to dissolve and leach into the surrounding water. Once the gold-cyanide complex is formed and the aeration process is complete, the slurry is sent to drum filters for filtration. Drum filters are large, rotating central filters with a porous surface that allows liquids to pass through while retaining solids. This separates the water containing the gold from the solid impurities. To recover the solid gold from the loaded solution, a chemical process called precipitation is used. Commonly used precipitation agents include zinc, carbon, or aluminum. These agents react with the gold ions in the solution to form solid gold particles. The solid gold is then separated from the solution through filtration, but it still carries a lot of impurities. To further purify the gold, it goes through a process known as smelting. The filtered material, often referred to as gold concentrate, is mixed with flux materials. These include a combination of chemicals like manganese dioxide, fluoride, silica flour, borax, and sodium nitrate. The flux helps facilitate the smelting process by reducing the melting point of the impurities and enabling the separation of gold from other elements. The gold concentrate and flux mixture are introduced into a specialized high-temperature chamber called a furnace. Inside the furnace, the mixture is exposed to temperatures as high as 1,600 degrees Celsius, causing it to melt. The furnace is rotated to ensure even heating throughout the mixture. The extreme heat effectively separates the gold from other elements present in the concentrate, such as base materials and impurities. As the material melts, it separates into distinct layers based on their densities, with the gold sinking to the bottom due to its higher density. The impurities, known as slag, float to the surface. Workers collect the slag and a sample is taken to ensure it contains no gold. If any gold is found in the slag, it is returned to the smelter and reprocessed until it is completely free of gold. Once the gold has settled at the bottom of the molten material, it is collected by tilting or pouring the mixture. Typically, the gold is poured into molds or casts, forming what is known as a doré bar or bullion. It's interesting to note that the doré bar or bullion obtained at the end of the smelting process is only 80% pure. To achieve the international standard of gold purity, which is 99.9%, the gold needs to undergo further refining. After the gold has been refined, it undergoes assay, which is the process of determining its purity and quality. Assaying is typically performed by specialized laboratories using various analytical methods, such as fire assay, atomic absorption spectroscopy, or mass spectroscopy. This ensures that the gold meets the required purity standards. The refined gold can be further processed into various forms depending on its intended use. It may be shaped into bars, coins, jewelry, or used in other industrial applications. Adhering to environmental regulations and guidelines is of utmost importance in cyanidation processes due to the significant environmental risks associated with the chemical if not handled properly. Quality control procedures are in place to ensure strict compliance with environmental regulations, preventing the release of excessive cyanide or other contaminants into the environment. Effective effluent treatment and waste management processes are implemented to minimize the environmental impact of the cyanidation operation. Thank you for joining us on this fascinating expedition here on Superstructures. If you enjoyed this journey, hit the like button and subscribe to our channel for more captivating content. Until next time, keep exploring and never stop learning.